Yes, welcome to. So here, last class, this is the part 3 in chemical properties of ammonia. We have studied about the chemical properties of ammonia in part 1 and part 2. There we had a discussion about the physical properties of ammonia and how ammonia acts as a alkaline and how liquid ammonia reacts with the dilute acids like HCl, H2SO4 and HNO3. And also we have studied about the ammonia, liquid ammonia, how it reacts with the salts, solutions of salts, salt solutions, and how it gives us precipitates. That is what about precipitation reactions also we have studied. And this class, after completion of this class, you are coming to know that you are going to know that you are coming to learn about the how the action of ammonia on metallic oxides, how it reduces metallic oxides into metals, and what about the liquid ammonia, how it reacts with liquid chlorine, and what kind of products will get at different conditions. Conditions means it may be temperature or it may be a ratio of the reactants also. So by the varying ratios of the reactants also will get a different products that you will get to know after finishing this class. Thank you. Thank you very much. Let us start the class. So ammonia as a reducing agent. You should remember that is the next property of this particular chapter, particular topic, ICAC 10th standard study of compounds, ammonia. Okay. So ammonia as a strong reducing agent. Basically, ammonia acts as a ammonia in reducing action. Ammonia gas that acts as a reducing agent. Reducing agent. How it acts as a reducing agent? Basically, ammonia being a strong alkaline gas. So this is what the experimental setup I have to take. So here I have taken, this is what we call it as fusion tube. Okay. So basically in a laboratory, to heat up of any for decomposition of any substances, either it may be solid or in liquid, we'll use the fusion tubes. Why? Because they have high ability to withstand up to high temperature around 3000 degrees centigrade. So now what I'm doing here, I have taken here one stand. That is what I can say. Just a minute. Fusion tube. That fusion tube you can see here. This fusion tube with the stands up to high temperature. Now in this particular fusion tube, I'm taking two kinds of metallic oxides which can easily reduced by passage of ammonia gas. So which two metallic oxides I have taken here? Lead oxide and copper oxide. So initially you should remember what is the color of the lead oxide. Basically color of the lead oxide is white itself only, white color. Lead oxide color is white in nature, white color. Okay, let me write. This is lead oxide is white in color. Okay, what about the copper oxide? Copper oxide is black in color. You already know that copper oxide is black in color. Okay, now what we are doing, we are heating both oxides up to certain degree temperature. When we heat both oxide in the same time, at the same time, we have to pass ammonia gas through the inlet wall. When ammonia gas comes here, that ammonia NH3 pass over on that heated copper oxide as well as lead oxide PbO. It converts, because ammonia behaving as a reducing agent, that reduces lead oxide into lead metal, lead oxide into lead metal, and also it produces water vapor there, water vapor. Along with the nitrogen gas gets released here. Nitrogen gas gets released. That nitrogen gas, N2 gas, will form, and we will, that nitrogen gas is passed through the U-shaped tube. That is U-shaped tube contains a water, because of we are going to condense the water vapors there. We are going to condense this water vapor in the U-shaped tube. Okay, so let us talk about the mechanism of the reaction. Here ammonia being a reducing agent, that reducing a oxidizing agent into lead. That means lead oxide into lead. Lead oxide undergoes reduction Lead oxide undergoes reduction that reduces it to lead metal. But here ammonia acts as a reducing agent. Okay, because of lead oxide is oxidizing agent. And we'll get two different products again. Okay, that lead metal remains in this tumbler. Okay, what we have taken here, either China dish. In the China dish only lead metal will remains, and water vapor and nitrogen gas being both are gaseous in state, that water vapors and nitrogen gas comes out from the fusion tube. And here we are going to condense the water here, because if we bring down the temperature below 50 degrees centigrade, the water vapors are below 100 degrees centigrade, water vapors converted into a liquid. But nitrogen gas will not liquefied around 100 degrees centigrade. The pure nitrogen gas will collect it in the downward displacement of water jar. Downward displacement of water jar. So this is what about the mechanism of the reaction. Mechanism of the reaction. Now let us go with just a minute. Okay, let me take this side aside. Yes, this is. Now let us write a few chemical reactions. Both chemical reactions takes place between ammonia and copper oxide, as well as ammonia with lead oxide, with observations, because this is very important topic for the board examination. Let us move now. So the balancing equations. How to balance the chemical equations? How to write the chemical equations? Look at here. You're supposed to remember, when we pass ammonia NH3 on hot heated copper oxide, CuO. CuO is nothing but copper 2 oxide. What happens to this? Ammonia having a ability that acts as a reducing agent, that reduces copper oxide into copper metal. What is the color of copper metal? What is the color of copper metal? So basically the copper oxide is black in color. When we pass ammonia on a hot black color of copper oxide, copper oxide reduces to copper metal, that is brown in color. We can say that a black copper oxide reduces to brown copper metal, brown color. And along with that, we will observe that there is a formation of water vapors and also nitrogen gas. Okay, nitrogen gas. So for this, they may ask you balancing equation. You are supposed to balance the equation. Let me write one more equation. Ammonia reacts with lead oxide. It produces lead metal, that reduces lead oxide into lead metal along with the water and nitrogen gas. So both vapors will pass both the vapors through the condenser. You can see from the above what is that diagram. Here we'll use a condenser, that is U-shaped tube that condenses water vapors, whereas a nitrogen gas is collected in a downward displacement of water jar. Why nitrogen is collected in a downward displacement of water jar? Means because very simple, because nitrogen is not soluble in water. Nitrogen is insoluble in water. Hence, to remove the impurities, if any missing impurities are there, means there in the nitrogen mixture, means we can easily remove the impurities from the by passing nitrogen gas through the water. So that is the point. Now let us go to the balancing equation. How to balance the chemical equations? Look at here. First we supposed to balance the elements. Here copper is there, copper is balanced. First you're supposed to balance the metal only. Okay, so copper balanced. Next let us go to the oxygen. Look at here, oxygen is balanced, and hydrogen is there. Here 2 is there, here 3 is there, no problem. Then nitrogen is there. Here 2 nitrogens are there. Here only 1 nitrogen is there, ammonia. So I can multiply here by 2 NH3. Now it is 2 means hydrogens becomes 2 into 3 is nothing but 6. But here only 2 hydrogens are there in the water. So I can multiply here by 3. 3 to 6. Now oxygen becomes 3 here this side. So here only 1 oxygen is there. I can multiply here 3. Now after multiplication of 3 in front of CuO, C becomes 3 atoms. So the reason I can put again here, see 3, then it becomes a balanced equation. So this is what the balancing equation for the chemical reaction of ammonia with metallic oxides. So, and observations. What is your observation? Look at here. Here, what happens to the copper oxide basically? What is your observation? Very simple. The black copper oxide reduces to reddish brown. Black copper oxide reduces to reddish brown copper metal. Observations are black copper oxide reduces to a reddish brown, we can say that reddish pink or reddish brown metal, reddish brown copper. So this is what your observations, very important. Balancing equations, observations, and action of ammonia, that is very important. Here what happens to this, when we pass ammonia gas on a lead oxide, actually lead oxide at initially that is actually white in color. On heating, that lead oxide turns to yellow. On heat, lead oxide turns to yellow. Now when we pass ammonia on the lead oxide converted into a silvery gray metal, that is what we call as lead. On passage of ammonia over a heated copper oxide, on passage of ammonia over a lead oxide that produces a grayish or grayish color of metal, that is grayish color of metal, grayish lead metal will get. Okay, so this is what your observation. Is it clear? So this is a point you have to remember. And nitrogen is collected over a water jar. Why? Because nitrogen is insoluble. That's all. Okay, so now let us go to the reducing action of ammonia or reaction of ammonia with the chlorine. How it reacts with the chlorine? Action of ammonia with the chlorine. Action of ammonia with chlorine. So here you can take both gaseous ammonia as well as chlorine also. Otherwise we can take liquid ammonia as well as liquid chlorine also. So liquid ammonia, how do you get? We will, if we reduce the gaseous state of ammonia, mean if we bring down the boiling point of ammonia gas below minus 33.7 degrees centigrade, we'll get a liquid ammonia. So let us go with the chemical equations. What happens here when chlorine to when ammonia used with the chlorine? There are 3 kinds of reactions. You can see here. I would like to show you here. So this is what basically
should not lead to any changes.
Listen, this is what basically the boiling point of chlorine as well as ammonia. So if we bring down the boiling points of chlorine gas and ammonia gas, we'll get the liquids like ammonium liquid and chlorine, ammonia liquid and chlorine liquid. Now we are treating liquid chlorine to the ammonia at low temperature. Look at here. There is a formation of fumes. That fumes are nothing but ammonium chloride. When ammonia reacts with chlorine molecule, that forms a nitrogen and what is that? Ammonium chloride. And also there is a possibility to form ammonia with chlorine. It only forms a ammonium chloride also. So in different conditions, these are the possibilities I am talking about. And if on excess of chlorine, look at here. Initially I have taken excess of ammonia. Ammonia is excess. Only little supply of chlorine we have passed. During that time, that produced ammonium chloride with nitrogen gas. Now I am continuing the addition of ammonia spontaneously with I'm adding large amount of chlorine to the ammonia. See how fast the reaction is taking place. What happens to there? When we take excess of chlorine with the ammonia, what type of reaction, what type of products we get? Look at here. We are adding excess of chlorine to the ammonia. It undergoes a highly exothermic in nature and it produces nitrosyl chloride, a nitrogen trichloride liquid will get. Nitrogen trichloride liquid will get. So nitrogen trichloride liquid will get. So that is actually highly exothermic in nature, and that reacts with the greenish yellow of excess chlorine and gives a yellow explosive liquids. Yellow explosive liquids. This is what about the chemical reactions of ammonia with chlorine. Let us go with now chemical reactions. Look at here. So an excess of ammonia, when ammonia and chlorine are mixed, if chlorine is reduced to, chlorine reduces to HCl here. Chlorine reduces to HCl, hydrochloric gas, hydrogen chloride gas. Let us talk now. What happens to that? When ammonia is treated with NH3 treated with chlorine, NH3 is treated with chlorine. Here I am taking ammonia as a excess. Ammonia as a excess. Okay. Ammonia, I am taking here excess of ammonia, treating with a chlorine. It produces, what it produces? It produces directly HCl plus chlorine. Sorry, HCl plus nitrogen gas. HCl plus nitrogen gas. This is what in first step. Okay. And also this ammonia, when it reacts with the, when we make a reaction of this ammonia with chlorine, on excess now we are adding some more amount of ammonia. This ammonia again reacts with the HCl formed in a first step reaction. HCl formed in a first step reaction, then it produces NH4Cl. NH4Cl. So overall, after balance the equations, then overall reactions we have to write. Okay. So balance, if I balance the first equation here, I can put 2 and 3 because of 2 3 is 6 HCls. Okay, and 2 nitrogens are there. That is the reason. Okay, that is balancing equation. Here NH4Cl, that is already literally it's balanced, I think so. NH3 plus HCl, NH3 plus HCl. Yes, it's balanced. But how many HCls are there? We got in first step, that is 6. So for 6 HCls, I should add 6 molecule of ammonia to produce 6 molecules of NH4Cl. So this HCl produced in the first step is consumed in the second step. So I can cancel it. Then overall reaction of chlorine with ammonia, what happens? Chlorine with ammonia, total number of reactant side, how many molecules of ammonia I used means that is totally 8 molecules of ammonia I used, and with the 3 chlorine molecules, that giving us 6 molecules of NH4Cl and 1 molecule of nitrogen. So this is the balancing equation when we use ammonia, excess of ammonia with chlorine. On excess of ammonia with chlorine, we will get the ammonium chloride with nitrogen gas. There is a point you should remember. So they may ask you to write a balanced chemical equation, for the reaction between excess of ammonia with chlorine. This is the actually this equation you supposed to remember, balanced equation. Now let us talk about what happens if we use chlorine as excess with the less ammonia. If we use chlorine, reaction of ammonia with chlorine, reaction of ammonia with excess of chlorine, what happens to that? Let us see now. Ammonia with excess chlorine, ammonia with excess chlorine, NH3 plus Cl2. This is actually excess. Ammonia with, you already observed the chemical reactions takes place in the test tubes. It undergoes highly exothermic. Ammonia reacts with the excess of chlorine. It produces HCl. And NCl3 compound. That is what we call as nitrogen trichloride. Nitrogen trichloride. So basically, so this is what about the reaction. Now how to balance the equation? I can put here 3 because of 3 hydrogens are there. Hence, I kept here 3. And after that, it becomes 3 chlorines. And here 3 chlorines, total 6. So I multiplied here by the 3. So this is what the balanced chemical equation for reaction of ammonia with excess of chlorine. So that is the point you have to remember. Now let us talk about the observations. What are the observations? What observations we can observe? So I have shown you the video also. What observations you might have observed there means I would like to go with the points now. First point, an excess of chlorine, an excess of ammonia with the chlorine, it produces lastly a ammonium chloride. That means an excess of excess ammonia reacts with ammonia with chlorine produces a dense white fumes of chlorine gives a dense white fumes of fumes of ammonium chloride. This is your observation in the first reaction. Okay, next reaction, what you can see there in the next reaction, that means on excess of chlorine with ammonia, you can see here a colorless ammonia gas. Basically ammonia gas is colorless, but the chlorine is greenish yellow color in nature. Greenish yellow greenish yellow chlorine gas turns into or it gives greenish yellow chlorine gas with colorless ammonia. It produces a yellow explosive liquid. Produces a yellow explosive liquid. Which is that explosive liquid means? Supposed to remember that is what nitrogen trichloride. So this is what about the reducing action of ammonia with chlorine and ammonia with some metallic oxides. Now finally the last topic of this chapter is that is test for the ammonia. How to test ammonia? Very simple way. You have to remember, when we bring a rod which is dipped in ammonia and bring that ammonia nearer to the HCl, that produces a dense white fumes. That is one chemical test to test the ammonia gas. And apart from that, what are the tests for the ammonia? When you bring a ammonium liquid solutions to the copper sulfate, that turns to pale blue color. An excess of ammonium hydroxide with that resultant mixture, the pale blue color turns to inky blue solutions. And also you can test with the indicators. When we pass ammonia gas on moist red litmus, that turns to blue. When we pass ammonia gas through the phenolphthalein, the colorless phenolphthalein turns to pink color. When we pass ammonia or when we add liquid ammonia to the methyl orange, the methyl orange color turns to yellow in nature, yellow color. So that is what about the action of ammonia on indicators. And by passing ammonia gas through the copper sulfate is also a test. And basically one point you should remember, this is very important for higher education. In higher educations you will study about this chemical test. What is this means? A colorless Nestler's reagent, that is Nestler's reagent is nothing but K2HgI4. Okay, how it changes Nestler's reagents? The chemical formula of Nestler's reagent is potassium mercuric iodide, K2HgO. This is actually colorless. When we pass ammonia gas through this colorless solution, when we pass potassium mercuric iodide or When we pass a colorless ammonia gas through the solution, the solution turns to pale brown. Pale brown. The solution turns to pale brown. Pale brown in color, brown on passage of excess of ammonia. So that indicates pale brown and it gives a precipitate. That is precipitate. So they may ask you, name the gas which turns Nestler's reagent into a brown precipitate. You should remember that is a gas is ammonia gas. That gas is ammonia gas. Yes. So this is about overall concept about the chemical properties of ammonia and uses you may study, not a problem. This ammonia is widely used in the preparation of what is that fertilizers in the agriculture field. Okay, ammonium nitrate, ammonium carbonate, urea we will use as a fertilizers in the agriculture. And also this ammonia is used to prepare a nitrates, so they are explosive in nature, so we can use that explosive nitrates to explode a rocks and all. Okay, so next point is it is used in the preparation of baking soda, and also it is plays very much important role in the research laboratories as well as medicine preparations, and it is used in the dyes as well as drugs also. And liquid ammonia we will use in the refrigerators to cool down the temperature. Okay, so this is what few examples or few uses of the ammonia is. So thank you. Next class we will meet with another chapter. Okay, thank you very much. And if you like my video, you can like it, subscribe it, and follow me. Thank you very much.